Greetings, fellow space enthusiasts. Recently, there have been some raised eyebrows and worried whispers about a simulated asteroid impact scenario conducted by NASA. Let me assure you, there's no need to panic. These simulations are not predictions of an imminent apocalypse. They are, in fact, a testament to our commitment to understanding and mitigating potential threats from space.
Think of it like a fire drill, but on a cosmic scale. Just as we practice evacuating a building in case of fire, scientists run simulations to prepare for the unlikely event of an asteroid on a collision course with Earth.
The recent simulation that caused a stir was designed to test our readiness and identify any gaps in our planetary defense systems. So rest assured, NASA is not predicting an asteroid impact. They are simply doing their due diligence to ensure the safety of our planet and its inhabitants.
Before we journey further into the realm of planetary defense, let's clarify what we mean when we talk about asteroids, comets, and meteoroids. Often used interchangeably, these celestial objects are distinct in their composition and behavior. Asteroids are rocky remnants from the early solar system, primarily found in the asteroid belt between Mars and Jupiter. Imagine a cosmic junkyard filled with boulders of all shapes and sizes, composed of metals and rocky materials. Comets, on the other hand, are icy bodies that release gas and dust when they approach the sun. Picture them as cosmic snowballs with tails that stretch for millions of kilometers made up of ice, dust, and other frozen gases. Finally, meteoroids are simply smaller pieces of asteroids or comets. They become meteors known as shooting stars when they enter Earth's atmosphere and burn up. If a meteor survives its fiery descent and lands on Earth, it becomes a meteorite. The history of our planet is punctuated by dramatic encounters with asteroids.
One of the most well-known asteroid impacts occurred roughly 66 million years ago, when a massive asteroid, estimated to be about 10 kilometers wide, slammed into the Yucatan Peninsula in Mexico. This cataclysmic event, thought to have triggered the extinction of the dinosaurs, serves as a stark reminder of the destructive power of these celestial objects.
But asteroid impacts are not confined to the distant past.
More recently, in 2013, a meteor exploded over Chelyabinsk, Russia, injuring over 1,000 people and causing widespread property damage. These events underscore the importance of vigilance and preparedness.
Fortunately, we are not defenseless against the threat of asteroid impacts. NASA, along with its international partners, has established a robust planetary defense program dedicated to detecting, tracking, and characterizing potentially hazardous asteroids and developing strategies to mitigate their impact risk.
The first line of defense is detection. NASA utilizes a network of ground-based telescopes and space-based observatories to scan the skies for near-Earth objects, including asteroids and comets that could pose a threat to Earth. These telescopes are equipped with advanced sensors that can detect even faint objects, allowing us to identify potential threats years, decades, or even centuries before they could pose a danger.
Once a potentially hazardous asteroid is detected, scientists carefully track its orbit and use sophisticated computer models to predict its future trajectory.
But detection and tracking are only the first steps. NASA is also developing and testing various methods for deflecting or disrupting an asteroid on a collision course with Earth. These methods include kinetic impactor. This technique involves slamming a spacecraft into an asteroid at high speed, altering its trajectory enough to avoid a collision with Earth. Gravity tractor. This method utilizes a spacecraft's gravitational pull to slowly tug an asteroid off course over an extended period. Nuclear option. While considered a last resort, detonating a nuclear explosive near an asteroid could vaporize part of its surface, creating a jet of material that would act as a rocket, pushing the asteroid off course.